Discovery documentaries with Citron Vans.
Our universe is definitely going to end. It's just a question of how and when.
That's the reason I became a cosmologist. I wanted to be the first person that would know how the universe would end.
The battle will be between two forces at the heart of the cosmos.
That tug of war is gravity, which is trying to shrink it down, and the expansion of space and time itself.
Will gravity prevail?
The universe will get smaller and smaller, hotter and hotter.
Or will expansion dominate and overcome?
Even the electrons around your atoms will be ripped apart.
The end is coming, and it could be sooner than you imagine.
How the universe works. End of the universe.
The universe is everything. All space, all time, all matter. The Earth is nothing more than a speck in comparison. A small rock, orbiting just one of the 200 billion stars in our galaxy, the Milky Way. And this enormous formation is itself just a drop in the ocean of galaxies that stretch for 90 billion light years. And all of this, from the largest galaxy to the smallest atom, will one day die.
We don't see evidence of anything being eternal. Eternity doesn't exist. Even space and time will come to an end.
The universe has been expanding since its birth, gradually burning through the fuel that lights its stars. But what will happen when all the fuel runs out? Will it all just disappear?
Stars die out, use up their nuclear fuel. We have an empty, cold, desolate universe.
Just dead remnants of stars, black holes, neutron stars. Eventually they decay away, and you're left with a thin haze of very low energy light. That's it.
It was thought that the universe would just gently proceed as it became older. But over the past few decades, astronomers have discovered a very different picture. The universe isn't gently advancing, it's in a violent struggle.
It may seem peaceful here on Earth on a nice sunny day, but in fact above us and all around us, throughout the universe, a battle is raging, and it has raged since the beginning of time.
Two forces strive for control. The first, expansion, pulls galaxies apart, cooling the universe, and heralds a frozen annihilation. The second, gravity, attempts to crush everything back together, destroying the universe in a big crunch. Will gravity or expansion prevail? Or will neither dominate? There are three possible scenarios.
One is the big freeze. Expansion wins, and the universe just expands forever. The second is that there's a delicate balance between the expansion and the amount of gravitational attraction, and the universe gets to a particular size and it pretty much stays there. And the third outcome is that the gravitational attraction wins, and the expansion stops, and the universe begins to get smaller, until eventually it goes back to a big crunch.
At the moment, the universe seems balanced between expansion and contraction. Will this equilibrium remain until it loses energy? Or will this fragile balance be disrupted?
I don't think there's any bigger question than where is the universe going?
To predict the future, cosmologists have looked to the past, back to the start of expansion, the beginning of gravity, the creation of everything. 13.8 billion years ago, an infinitely dense, hot speck ignited and suddenly expanded outward. That was the Big Bang. And all energy, all space, and all matter, the very building blocks of the universe seen today, were created.
you see around us, concentrated into a primordial fireball that exploded, sending all the galaxies into motion.
The initial blast, the start of expansion, is still continuing today. Without it, the universe would not be large enough for the stars and galaxies to exist in. Expansion is an astonishing force of nature and works by inflating the fabric of space-time.
Space between galaxies expands, and it pushes the galaxies apart. Space carries objects with it, like a surfer on a wave.
It's going on in every part of space. Even inside your body right now, there's a pressure for space to expand.
Expansion created the vast space for the universe. But if it had been unrestrained, it could have been a force of obliteration.
If the universe had been expanding much faster, it would have emptied out so fast you wouldn't have had time to make galaxies, planets, people.
The fact that we're here means that something must have slowed expansion. And it was the force that holds everything together. Gravity. Gravity and matter are closely connected. The more massive an object, the more pull it exerts on everything around it. It draws atom to atom, particle to particle, building stars, nebulae, galaxies, and the very structure of the universe seen today. Yet too much gravity, and the early universe would never have developed.